Hey there everyone. Make sure you got your coffee today because you're going to need it. We're going to go inside an architecture where we talk about emulating data from a clinical device, radiological data, medical imaging data, EHR data, like data from Epic or Cerner, all wrapped into our favorite data estate management system, Microsoft Fabric, and analyze with Fabric tools like data agents, data real-time dashboards, and data in Power BI reports. Stay tuned for today's episode of Pandalytics. Okay, let's talk about this end-to-end architecture before we get into the GitHub, where we go into the actual components. You see at the bottom all the services that are involved in making this whole end-to-end system work. AHDS, Azure Health Data Services, Fabric, real-time intelligence inside of Fabric, data agents inside of Fabric, and DICOM GitHub repos. So inside of Fabric, we have healthcare data solutions here. We have DICOM medical imaging come from a public repo, TCIA. We'll go over this in the video a little bit later. Artificial intelligence agents, Power BI Direct Lake, and OHIF, which is an open source freebie DICOM viewer for viewing radiological imaging, an agent that's inside of Fabric that helps cohort all of your studies together, and then underpinning everything is where we're storing all the data in Microsoft OneLake here. So this right here is kind of the key to where we can harmonize all of these different types of data. Isn't that cool? All right, let's keep going, shall we? So here's the end-to-end architecture. So if we look at it here, we have two big separations, an Azure and then a Fabric resource grouping. Inside of Azure, we talked about some of these things here, including the storage, some of the ancillary systems that help out and facilitate how we get data in and out. Inside of Fabric, we have a lot of things that we're going to go deeper into. Here's the infrastructure and how we ingest. You will need these. These are provisioned for you, but you'll need the ability to provision these things as you go through inside of Fabric and inside of Microsoft Azure. These things are very, very important. Next up, we have inside of Fabric, how we enrich the data, tie the data together inside Fabric using and analyzing in data agents, and then enriching that data and flattening it out. Also, in all of these things, you have a duration, and because we're dealing with a lot of data, some of these things take a while. And lastly, we have the ability to analyze radiological data. So this is the MRIs, X-rays, and things like that. And these are the components that are required for that. Last but not least, we have an overview of our agents and reporting. So here are the different agents that are deployed, a cohorting agent, triage, and patient 360. You can see some of these examples. You don't need to remember these. I have this all documented. But if you notice here, these are different types of data, real-time KQL data and batch or after the fact data with SQL. So this is how you get started. We have 10,000 patients and records. We have 5 million plus or so clinical resources, simulated 100 medical devices, 3 agents, 6 workloads, and around about 2 hours. It's a lot of fun. Let's dig in. Here we are taking a look at the actual infrastructure that gets deployed after you're done with everything. This is a general representation. This is a lot of stuff. We don't need to actually understand everything that's going on here. Just know there are 2 main distinctions, which we'll go through on each individual phase's deep dive. There are 3 phases, by the way. The first part is the Azure side. So this is the stuff that sits as infrastructure in your Azure subscription. And then there's the Fabric side, which is more the analytics, business intelligence, and data estate harmonization. So that's that. Let's first take a look briefly at what gets deployed inside of Azure. So on that previous nice diagram, you saw all these things represented. Don't worry about this. It is all deployed for you. You don't really have to memorize anything or anything like that. You specify the resource group name and where you want to deploy things, and you're off to the races. Then, so this is in phase one. So this is kind of the foundation. Then in phase one, you get the Fabric workspace and a few bits, but in phase two, it starts getting fleshed out into the analytics layer. So the analytics layer, or the business intelligence layer, I should say, looks like this. I have a few pieces of information that are live and streaming, and then I have a few pieces of information that are batch and have been sent over from our EHR, like Epic or Cerner or something like that. And these two things are the live bits. So I am getting live information about devices that are alerting me about low blood oxygen levels and high pulse rates. And they're showing at different hospitals or where they may have been admitted before. So from here, I can see where on the map I'm getting alerts from. And then on the patient monitoring, and this updates every 30 seconds, I can see, based on a singular device, some trends and things like that, but also all critical alerts coming in, and if my devices that are supposed to be monitoring things are in fact online. So I could have another alert, or maybe a Teams message fire, if any of this stuff happens. Pretty cool. Then I can take a look at, remember, we're taking DICOM images or X-rays and MRIs and things like that, and tying it to those folks that have our little finger monitors for pulse oxygen and things like that. And maybe I want to tie in, oh, I'm getting alerts. Maybe I should go look at a chest X-ray for any of those folks that are having problems with a high pulse or low blood oxygen levels. And say, well, you know, this Abraham Strossen, he has a digital rad image. And then for Alejandro Valdez, I have CTs. And then for Lisa Thompson, these are all fake, by the way, fake names. That's why they have these numbers behind them. I can see she also has some CTs as well. I can do some modalities and try to find male, female, and kind of make a cohort by myself. Or I can use the last bit that is deployed as part of this entire thing. I can use agents to query how I can get a bunch of cohorts together to analyze what's going on using live data plus data from our EHR plus information from our radiological vendor like Siemens or maybe Merge or Spectra or something like that. So let's throw a query here. Let's see what's going on. I'm going to say, let's find all patients who have had imaging studies, conditions and imaging details. So this is not going to give me live data, but it's going to give me information about folks that have information from radiological and from our EHR. So you can see the steps that are going through. And by the way, this is also deployed for you. It says, hey, you know, nothing's here for CT images. I had a hiccup there. And it's the first time I ran the query, it returned nothing. I asked the query again. It returned exactly what I expected. And it gave me some information about Abram Strossen, who, if we go back to our imaging report, remember he was up here. He had a couple of DICOM files in our history. And it says, hey, I have a couple of DICOM studies that are in our Azure stuff that we're deploying, and here are all the findings that we had from that particular patient. These are all pre-built studies. The images are all pre-built coming in from this TCIA organization's repo for testing. Remember, we are generating patients. So in the subsequent part of this video, I'm going to talk about how we tie all these things together. Just know this is how I can interact with the data. Okay, so what about a 360? How about we take a look and see if we can get a full patient summary for somebody with one of our fake devices. And let's see if we can get some live data here with active medications, any imaging studies, and so on. So I'm getting active meds, vitals coming from this device, and then any imaging studies that that person may have had. So if you notice here, I have already pre-built some of these things, so it interprets my information here. And if you ever want to look at how these things are set up, you could take a look at some example queries and the data source instructions and things like that. So it came back. It says, hey, this person has no active medication, no imaging studies, but this person, Leanne Aubrey Hintz, has some current vitals. The latest is about 30 seconds ago, and she has a low pulse, blood oxygen saturation and a high pulse rate. This is pretty bad. And here are all the findings. There's an obesity finding that she's under stress. There is a review due for medication. And these are all coming from the EHR database and the real-time data. So this is all data that is kind of more static or changes near real-time or maybe nightly. And this is the information that is coming through now. And we're combining them together to get a full 360 of the patient. And then finally, I have one more agent that does triage here. So I had a previous conversation a few moments ago that says run clinical triage, show all the patients, and flag anyone with opioids or recent surgery. And if you can come down here, it says, hey, here are some patients that are of concern. So here in phase 0, the overview, we went through at the very top, we talked about the phase progression, right? So let's scroll down from the top and start with phase number 1 here. And inside of phase number 1, I have in the overview at the very top that it deploys all Azure infrastructure. It generates synthetic clinical data, so data from your EHR like Epic or Cerner or something like that. It loads it into FHIR and DICOM services, and then simultaneously it builds a Fabric workspace with a real-time intelligence pipeline, and then everything builds on top of it. So let's look at how this looks all together. So here's the Azure side, here's the Fabric side, and these are all the things, all the widgets that are deployed here. And I will advise you that when you generate the synthetic patients, it does take a little bit, and this is the bulk of the time for phase 1, is building out those patients and also getting the the demo images, medical images like radiology images like chest x-rays and CTs and MRIs into your environment that we're going to use to simulate exploring or double-clicking on a patient that is having some issues, which is going to be a lot of fun. But these requirements are all deployed for you, and all the interconnectedness and identities and all that fun stuff are deployed on your behalf. So you don't really have to do anything except execute the deploy all script that we talked about in the last video or portion of the video. Okay, so let's scroll down a little bit and talk about the base infrastructure, and it's in the deploy script. We talk about the event hub that's needed, that's going to capture all the real-time streaming data coming from our simulated finger sensor that is going to test for blood oxygen and so on. We're going to store our simulation services as container images to deploy to compute. So that includes synthetic patients from Cynthia, as well as synthetic locations, like all of the Atlanta area hospitals that I'm using to be synthetic patients. So patient A goes into Children's Hospital or Healthcare of Atlanta. Patient B goes in the Piedmont Hospital here in Atlanta, for example. You can customize all these things for your neck of the woods if you'd like. And then they all get loaded into a FHIR service that is part of the Azure ecosystem. But to fling all those patients up into that FHIR service, we need a loading mechanism, and that's what this is. And then the last container image that we're using is to take all the publicly accessible CTs, MRIs, and whatnot from the TCIA repo, and then fling it up into a common spot for us to use later on down the road. The Event Hub connection string is stored in a key vault to keep it away from being hard-coded. And then the actual container, once the image is deployed, the container simulates the Radius 7 style Masimo devices. They are pulse oximeters that give us pulse ox saturation, pulse rate, and perfusion indexes, or indices. And if you just want to deploy phase 1 by itself, here is the command. And it does check for all existing infrastructure before it deploys. So it's going to say, hey, you've already deployed this stuff. Don't redeploy it again because it'll take a lot of time. If you want it to, you can force it, but it does validate that everything is there. So if you run it again, it's not going to redeploy something for you. Now in step 1B, we deploy the Fabric workspace, and here is a key part. It creates the Fabric workspace early, so if you can, jump into that workspace and deploy the one manual step that all these scripts cannot do, which is create a healthcare data solution for us. And we're going to go through that in just a second. And it does all this fun stuff as well. And mainly creating a workspace identity that we can use to take from a Fabric, talk to the Azure stuff without needing to exchange credentials. Then the second step of phase 1 is to deploy the FHIR service, Cynthia, and then load it into the service. So this fun stuff talks about that. One of the key elements here is a patient count. So the default is 500, and it is for Atlanta, Georgia metro area, which you can change. And this talks about how you load it in there. And crucially, Cynthia doesn't necessarily tie synthetic patients to synthetic PPG monitors that we're using for Masimo. They don't know about each other. So there's a tiny little Python script that marries those two things together to say patient John Smith, that is fake, and Masimo device 0001 are now associated with each other. So all of my metrics, John Smith has a fictitious oxygen saturation drop below 80, which is a critical event. Tying that together is very critical. So it's going to take some of these SNOMED CT codes like asthma, diabetes, hypertension, COPD, heart failure, so on, and associate them to those patients. Very cool, huh? Now, we have real-time data, we have clinical data. Now we need to marry up some radiological imaging data together. And this is the last kind of major component here. So if we take a public repo from the TCIA we talked about in the last segment, and we load it into a DICOM loader, and then we do the same thing we did with the real-time data, is we re-tag those studies, the radiological studies, with Cynthia synthetic patient IDs to marry those together. and then fling it all up into the FHIR service to make sure that we have a simulated Epic or Cerner that has basically the source of truth for all of our fake synthetic patients. So here are the actions that the script takes and all that fun stuff. Now, we're going to set up the real-time intelligence, RTI, in Fabric in phase 1 as well. So this is setting up some basic things that we're going to need to be the receptacles for all of those real-time device data updates. John Smith has dropped below 80. John Smith has risen above 92, or whatever. So these are all the necessary components for that. And here are the KQL files. And then I built in some clinical alerting tiers. So when we look at the real-time dashboard, you'll understand, oh, this is a real big issue, or not really, or this is critical. The pulse ox is below 85, and the patient has COPD, and the pulse rate is greater than 150 or lower than 40. That means, we should send an ambulance to them, right? So the real-time dashboard has all of these things built in. And this is the kind of layout of all those things and how our functions relate to those different tiles on the dashboard. And then in step 4, I call out the manual step. So if you deploy phase 1 and as it's deploying, you don't deploy healthcare data solutions, after phase 1, it will stop and say, hey, you need to deploy healthcare data solutions inside of Fabric before I can continue to phase 2, 3, and so on. So this is the step-by-step on how to do that. And we'll go through that in just a moment. And this is how you click go, right? So if you notice here, full phase 1, and there actually, if you deploy during phase 1, if you deploy that one manual step at the end of phase 1, if it detects that manual step has been performed, it will go to phases 2 and 3 on its own. You don't have to do anything else. So when I was testing this, what I like to do is allow the phase 1 script to get to the part that it deploys the Fabric Healthcare Data Solutions industry solution. And then, because it takes a couple of hours for everything to complete, go away, get some coffee, do something else, come back, and the entire thing is deployed. So I'm going to step us through that exact process in just a moment. So if you want to, and you've already done a portion of what phase 1 does, you can pass these parameters along as well. And once phase 1 is all done, you get about 10,000 synthetic Atlanta area patients. You get 250,000 encounters, office visits, hospitalizations, call-ins, whatever. Conditions, observations, vital signs and labs. Again, they're coming from our PPGs. Immunization, all this fun stuff. Do we need immunization? Not really. But what I'm expecting is if you take something that has an end-to-end emulation, like what we are doing here, you might think of other things that you could use this for in demos, and maybe not with synthetic patients, maybe your own patients coming from Epic or Cerner or whatever. And that's the idea, is to make sure you have a skeleton, a foundation that you can use to analyze your entire clinical estate. Okay, at the bottom here, we have a phase 2 link to let us go to the next phase. So I'm going to go through the next 2 phases, phases 2 and 3, and then we're going to jump into the code and deploy it all together. Sounds fun, right? Let's go. Okay, on to phase 2. Now, phase 2 takes real-time telemetry and the FHIR data and throws it into healthcare data solutions. If you're not familiar, healthcare data solutions is an overlay to Fabric that is healthcare oriented and helps you rationalize and flatten out healthcare data into a common format based on fast healthcare interoperability resources, or FHIR. Then KQL is our real-time analytics language, markup language, I guess, and it is also the name of our database. So when you have real-time data coming in, a specialized database like KQL database is really good to receive that data and then do analytics on the fly. And then we're going to take KQL database, which is a specific type of database, and then shortcut, which is a one lake feature that says, hey, real-time data, point back to the information from the clinical record of truth. In this case, we're simulating Epic or Cerner. And then marry up patient name with real-time analytics coming in. So again, we use that example of John Smith, getting the patient name from FHIR data, because the real-time data coming in will just say Massimo device 001 has a test that the blood oxygen level is below 85. And then the KQL database with the shortcut will reach back to FHIR, the clinical record, and get the patient name and marry them together. And then in our little dashboard, we can say, oh, John Smith with Massimo device 0001 has dropped below 85. And it is a clinical, it's a very big deal, right? Now, we're going to deploy this, and it's going to kind of enrich the data that we've had coming in. So let's go through this. And this does take about 35 minutes to deploy. It's just FYI. Make sure you are getting some coffee or whatever else you're doing. And most of this takes place inside of Fabric, as you can see here. So we have our export of all the data that we, in phase one, produced synthetically and married up together and threw it into the FHIR service. Now, from the FHIR service, we do what's called an export. So that export puts everything in a common format called NDJSON. And the Healthcare Data Solutions, which is the overlay to Fabric that does the harmonization of all clinical data, needs that format to continue. And it makes sense because when we interface with healthcare data, we need it to be in a common format and we need it to be open. So NDJSON, or New Line Delimited JSON, is the data type. It sits on disk inside of ADLS Gen 2, but according to Fabric, it looks local using that one lake feature called a shortcut. And that's what I'm calling out right here and here. So inside of Healthcare Data Solutions, we have a construct in Fabric called a lakehouse. And that lakehouse allows us to have a kind of a holder for all those files that were exported from the FHIR service. And then once it's in this holder, I can do a lot of things like flatten it out, make sure it looks good in tabular format, understand the data, and then, crucially here, we need to marry up the data. And the marrying are those delta table shortcuts that I have here. And those are leveraged through functions to throw out onto a dashboard. So the function says, hey, do a select star. And I want to take all the data coming in from my alert history and telemetry. And then I want to take the patient and condition and device and in my function, call it out and say, throw it into a dashboard. So you'll see in the dashboards, the backing or the queries that power the dashboard are actually these functions that do the marrying for us, do the tying for us. That's really fun. You see some data agents, the foundations of the data agents be deployed. We're not going to get into that yet. Phase 3 will handle a lot of that. All right. So I'm going to click out of this, scroll down here. We talk about the shortcuts. We talked about the shortcuts to the clinical and DICOM data in the bronze lakehouse, and the KQL database shortcuts back over to a silver lakehouse after it's all been harmonized. The bronze lakehouse is raw data, by the way. Silver lakehouse is I've taken the raw data and I've done something with it. I've cleansed it, I made it flattened out. In our case, we're flattening it out. Meaning that data coming out of a FHIR service is very complex and gobbledygook, and a lot of key value pairs. The silver lakehouse is tabular data, so flattened out and normalized with multiple columns. So our KQL data is married up to the flattened or more cleansed version of the clinical data. That's the difference. And we talk about all this fun stuff in the functions that we were just talking about, and the dashboards that we were just looking at, shortcut and pipelines that do the flattening for us and the marrying for us. The data agents are here. We are throwing out the data agents and putting some instruction sets in there, but we're not going to invoke them and do a lot of configuration until we get to phase 3, where we'll wait for phase 3 to complete, and then we'll come back and reference this to test the data agents. I gave you this kind of nice matrix so that you can come back and just say, hey, it is in fact working the way I want to. And each one of these data agents that we're going to use natural language with to analyze the data coming in, the synthetic data, all have kind of like what the 360 means, what the triage means, and what the cohorting means. So 360, you can do a unified patient view across real-time telemetry and clinical data, triaging support decisions for alert prioritization, send the ambulance, right? And then the cohorting will be covered in phase 3, okay? And this is how you deploy phase 2. If you didn't catch deploying HDS in phase 1 and it didn't automatically deploy phase 2, you pick it up and you just run this command again, which we'll go through. All right, now let's move on to the final phase, phase 3, where we talk about imaging and the cohorting data agent. All right, now we're on to the final phase, phase 3, where we talk about image report and cohorting. So as the overview says, we have a clinical imaging layer where we can invoke an external viewer to look at the images that are actually housed in OneLink. And then we have a natural language data agent that cohorts a bunch of different maybe disease groupings or demographically interesting folks, like all males over the age of 32 presenting with COPD, for example. And it uses that using one of the HDS modalities, one of the healthcare data solutions modalities in Fabric, called OMOP. And OMOP is actually a researching clinical standard. And that researching clinical standard de-identifies data from the patients and just says, oh, here's patient 1, 2, 3, over the age of 32, presenting male, presenting with COPD. Pretty cool. We'll also go through the Power BI report as well. And this is actually a pretty fast step, fast phase. There are 7 steps in it. And here are the kind of components here. We deploy the OMOP Lakehouse, which should have been already deployed in Healthcare Data Solutions deployment step. It deploys that final agent, and then the reporting layer, which we materialize some views coming from our lake houses so that they can be used in a static web app to tunnel back over to OneLake and pull images out and then display them inside of a browser. So I'll show you what that looks like. Basically, it's a link on a Power BI report that says, I want to look at John Smith's chest x-ray, and click a link, and it throws up another tab and invokes all the Azure resources to read the image and in a secure manner using your credentials to do that. All right, that is pretty much the end of the architecture. And this is the data agent that maybe you would use to combine patients, or like I said, look for demographically important patients. And cohorting is a very common thing in research or in business analytics if you're trying to find some trends with patients in a certain area. Maybe more rural would present with more of a certain condition or not. Those types of things are very interesting. That's why the cohorting agent is here. And the DICOM viewer is kind of a bonus. Do you need to see the X-rays or the CTs or MRIs? Not necessarily, unless you are a business analyst with a radiological background or know how to read the films. But if I'm a researcher and I am trained to read the films, I can find all patients with COPD presenting and then review the individual films from all of those patients to see if, oh, well, not only do they all present with COPD, but they have a certain type showing on the X-ray film. That's why I included it here as kind of like a bonus. And this is how we use this. A clinician or a clinically trained researcher uses a browser and connects to all these things and using some open standard formats and things like that. The last thing that I would like to go over is the report. And the report is where we have those links to go back and see how many patients are presenting with certain things, and also give us the links to view the DICOM images if we'd like to. So basically, we have cross-references, clickable links, and demographics that you can use to see all the different imaging studies. This is how you deploy it. Same thing, phase 3, and it's the same capabilities that we've been talking about, the same way we deploy things as well. Now, the phase 3 is actually a different repo that I actually posted a video about by itself. So all this is saying is, hey, this is actually coming from Joey's previous work, and here's a link for it, and here's what all those things do. Okay, we're at the end of the overview of how this all works. Okay, I hope you got your coffee ready, because now we're going to get into the code. So in all the overviews, I showed you exactly how to deploy each thing. So I'm going to go through exactly each one of these steps and illustrate how to deploy phase by phase all these things, so you have a working prototype like I showed you at the beginning of the video. Here we go. Okay, here we are, and everybody's favorite, the terminal. So we first start by deploying or cloning our GitHub repo so that we can deploy all phases 1 through 3. So we clone here. This is the command to clone. If you don't know how to do that and get this URL, it's actually here in the GitHub repo that we've been looking at. It's in the comment of this YouTube video. This is the URL that we are using. So we'd copy that to clipboard and say git clone. So I've already done that, so we don't need to do that. If you notice here, I'm in the cloned repository already, and you can see that I have all of the stuff already cloned here. I'm just going to blow this up a little bit. All right, so if we look back at the documentation and we go down to the quick start here, I talk about the prereqs that I mentioned in the overview, and this is the primary phase 1, but also phases 1 through 3, because remember, during phase 1, if you do the manual step of deploying HDS in the Fabric portal, then it will continue to phases 2 and 3 on its own. You don't need to interact with it at all. So actually, I mentioned when we went over phase 1, that if you can catch when it creates the Fabric workspace and deploy HDS ahead of time, then you can just kind of set it and forget it. And I do put the Fabric workspace creation really close to upfront in the deploy all script. So what I'm going to do though is, because I already have this out there, I'm going to do a full teardown and show you that script first, because I already have these resources. So I'm going to do that real fast here, and I'm going to change these workspace names around because everything I showed you at the beginning of the demo is still there. So I'm going to go into Fabric and go into Azure and grab those names. So you see this is the name of my workspace I want to tear down. And then I'm going to tear down my resource group here. All right, so I'm going to plug those guys in real fast. And that's just date 0327 and click go. And you can see this is going to go through all of the infrastructure that we provisioned in the normal script and just tear it down. I'm going to hit pause here. It's nothing exciting. It just does a loop to see when things delete, and we'll come back to it. Okay, it's still deleting, but what I'm going to do, because the resource group name and the Fabric workspace name, I'm going to increment by 1 day because I've been giving a suffix of the date. So it's not going to really interfere, and I don't need to actually wait for this to complete, but just to show you that things are deleting out. Here is the resource group, all 20 or so Azure resources, but 3 have been deleted so far, and they are in a status of deleting here. So just to let you know that no magic is really going on, no voodoo here. And this workspace will be deleted in just a moment at the end of the script. But we don't need to wait. Like I said, we can just go ahead and provision a new instance of this entire thing. And you can too. So I'm going to just pull up another tab here and cd into that directory that we cloned and paste in the new resource group name, the 28th, and the 28th of the workspace, so we don't have any conflicts, and click paste. There's no issues here. I'm going to click go. So the first thing it does is it says, hey, I need to see if there's anything out there. Remember, it's idempotent, so anytime that you deploy something and it already exists, it won't redeploy. But because nothing exists yet, it's going to go through a full deployment. So inside of Azure, we're going to start building this resource group. And then inside of Fabric, we're going to start by provisioning this workspace. Remember, if we can get to this workspace right after it gets created and deploy HDS, then we don't really have much else to do, except wait maybe an hour-ish or two and come back to this and check on it and see that everything is working. Okay, so it is still deploying here. Let's go into Azure and check it out. Let's see if this guy's deleted. This is the old one. Hasn't deleted just yet. I'm going to come back in my Azure and go into my resource groups, and I should see a brand new, yep, there it is, resource group, and things are starting to get created right now, right? So we're going to wait just a moment for the workspace to provision for us. I'll check on this real fast. Okay, the infrastructure is ready, and we've assigned my security group that I'm using for everything I'm doing in Azure and inside of Microsoft Fabric. So my login is a part of this. So that's how we know I am authorized to use everything that I'm deploying in the script. If you don't have a security group, make sure you can create one, because it makes life a lot easier. And you can just pass it to the script and not worry about any permissions or getting access denied or any of that fun stuff. So it's building out the images here. And let's go ahead and check back on Fabric to see if this guy's been deleted. Not just yet. We should see, this is our real-time device emulator that we talked about in phase 1. This is the pulse oxygen emulator that constantly sends device information, metrics, and telemetry over to Azure to be consumed in Fabric. So that's what's deploying at the moment. All right, that's done. So step number 2 is creating the workspace. So now it's creating the workspace that I gave it in the script. And it says, hey, does Joey have any capacities that he can assign? So my login, do I have any capacities that are online that I can assign to the workspace? If not, there probably is a trial that you can use in deployment. But remember, if we deploy a trial, we can't deploy the data agents, which is kind of the real reason why we're deploying this. So it says, hey, I have a SKU online, it's ready to go, it's assigned. So that just took less than a minute. So now let's do that manual thing so we don't have to sit here and babysit the script when it comes back. Okay, great. This was my old workspace. Remember, it was deleting on the other tab. Let's see if it's done yet. Sure enough, it's completed. It took 7.5 minutes and deleted everything. So that's why I got this error message. But now that I've refreshed, I should see a new Fabric workspace that we started provisioning on the other tab here, this tab that is provisioning. And sure enough, this is 0328. And here is the crucial manual step. This flashing, blaring signs here, this is the part that allows for the script to execute end-to-end without any other user intervention. So I'm going to click on New Item and click on Healthcare Data Solutions, which if you've never deployed it, it's at the very bottom here, right here. And we are just going to allow the solution to create. We're going to click this Set Up Your Solution here. We're going to click Next. We're not deploying sample data. We're doing it ourselves inside of Azure. And we're going to do two things. We're going to enable DICOM data transformation and enable OMOP transformations. And then click Next. Now, if you want to, you can deploy anything else in here, but these are the only two things required for the script. And click Next again, and then click this little I have acknowledged and read and agree to the above. And last thing we do is hit deploy. So that took me, 20 seconds. And now I can go back to the script, monitor it, but I don't need to babysit it. So I'm just going to hit pause on the recording and come back to it at the very, very end to do a deployment summary. Okay, coming back, it took a little over an hour and a half to deploy everything. If you notice here, what took the longest was the HDS pipeline. That's taking all that synthetic data, taking it in, ingesting it, flattening it out, and making sure that all those widgets that we talked about, the real-time information, the dashboards, the Power BI reports, the data agents, all can source that data in the proper format, ready to be deployed. You can ignore this. We did the manual step already. I'll actually probably take that out in the final version of the script. If it detects that in phase 1 we did the manual step already. But that's about it. So let's go over to Azure and Fabric just to make sure everything is there. Let's see here. Okay, we're over here in Fabric. We can see that our report is populated correctly. I can see that there are DICOM files associated to those synthetic patients we created. We're going to take a look here. I've already run a single query, but let's do this. Let's do a nice quick test. Which patients have low SpO2 blood set ox? And while we're waiting on that, we can also come back to this and see that, yes, indeed, we do have live data coming in. And we can come back to our Lakehouse, which has all of the information from that's been consumed by Cynthia, our synthetic clinical data, as well as the imaging data from our DICOM. As well as any information related to around those patients, like facility and location, like those locations that we have in Atlanta and so on. So that's all good. Fabric checks out okay. And then this is the Azure side of the house. All those things were deployed for us with that single script. That all works. And last but not least, we should check that imaging linkage just to make sure that the DICOM viewer deployed correctly. And sure enough, we have our X-rays and CTs and things like that all working fine. Oh, yeah, let's check that response from our clinical triage agent. Sure enough, that worked just fine. So, just a summary, we deployed our entire end-to-end repository, starting with generating some fake patients, loading it into a FHIR service, taking those fake patients and tying resources like MRIs and CTs and X-rays to those fake patients, as well as tying real-time data streaming in by the second from fake PPG devices, all harmonized over here in Bronze and Silver Lakehouse, as well as real-time data streaming in over here, and then consumed by all these agents and real-time reports and dashboards working just fine. And we can actually view we can also view images, medical images from the static web app here at the bottom. So that really wraps up the entire end-to-end emulator. Well, you probably guessed that it was more than one cup of coffee. When I started, there was still daylight outside, and now after editing the video and getting everything recorded, it's now a little dark. But I wanted to say thank you for sticking with me to learn about real-time, near real-time, and batch data coming in under one roof inside of Microsoft Fabric for healthcare-specific data, showing end-to-end multiple modalities and multiple ways to consume that data with data agents, reports, and real-time dashboards. If you like this content, please like and subscribe to the channel. Please comment on the video. And then also, please find me on LinkedIn. I love to talk about this stuff. This was definitely a labor of love. And come back to this channel. I'll have more content as the days progress. Have a great day, and I'll see you on the next video. Take care. Bye-bye.